Imagine a galactic club, a bustling community of civilizations exchanging knowledge across the stars. It's a vision that fuels science fiction, but reality is far less forgiving. When we peer into the universe through the lens of one-dimensional hyperspace, we confront a sobering truth. We are not simply alone by accident. The very laws of physics seem to have quarantined us. Invisible barriers of distance, time, and velocity stretch across the cosmos, walls no technology, however advanced, can fully overcome. Even applying the Kaku scale of technological advancement, our fledgling Type 1 civilization is confined to a local neighborhood that is essentially a desert. Consider Proxima Centauri, our nearest stellar neighbor. At just 4.24 light-years away, it might seem close on a cosmic scale. Yet, with our current fastest spacecraft, the Parker Solar Probe, which reached 430,000 miles per hour, a journey there would take over 6,000 years. That's longer than all of recorded human history just to reach the front door of the galaxy. This is the first wall, the staggering scale of space. Stars in our region are separated by an average of 5 light-years. The galaxy is not a crowded city, but a scattering of isolated islands surrounded by immense, cold voids. Light itself, the fastest traveler in the universe, takes years to cross these gulfs. Physical separation alone ensures that contact between civilizations isn't merely difficult. It's virtually impossible for any species bound by the standard model of physics. Some may argue that advanced intelligences could simply move faster. Here enters the second barrier, absolute and unforgiving, the universal speed limit. Einstein's special relativity, formulated in 1905, fixed the speed of light at exactly 299,792,458 meters per second. It's not a suggestion. It's a cornerstone of reality. As objects with mass accelerate toward this limit, their mass grows and the energy needed to push them further rises exponentially. Reaching the speed of light would require infinite energy, an impossibility in our finite universe. Even speculative ideas like warp drives or wormholes face insurmountable challenges. The Alcubierre drive, which mathematically suggests writing a contraction of spacetime, depends on exotic negative mass matter that has never been observed in a stable form. To stabilize even a microscopic wormhole would demand energy equivalent to multiple planets. Supporting a bridge between stars using effects like Casimir would be like holding up a skyscraper with a single feather. The physics of the universe simply refuses to bend to ambition. Let's say, for argument's sake, a civilization could build a ship traveling at 10% the speed of light. Even then, the engineering nightmare is monumental. Accelerating a modest 1,000-ton spacecraft would consume energy equal to detonating 150,000 nuclear weapons, more than all the nuclear arsenals on Earth combined. And space itself is far from empty. At relativistic speeds, even a single hydrogen atom carries the kinetic energy of a high-velocity bullet. Traveling through this sparse medium is like sandblasting a ship at unimaginable speed. Without meters of protective shielding, the craft would be shredded before leaving the Oort cloud. Quantum mechanics reinforces this isolation. Every attempt to bridge the stars confronts a universe designed for solitude. Signals to even a nearby star take years to arrive, and replies take twice as long. A simple greeting sent to a star 1,000 light-years away would return 2,000 years later, long after the civilization that sent it may have vanished. We are like fireflies flickering alone in an endless dark forest, separated not just by space but by the relentless march of time. Even if we could harness energy on a Type 2 level, drawing power from entire stars, interstellar travel remains a mechanical nightmare. At 10% light speed, the cosmic medium becomes a deadly minefield. Dust grains and hydrogen atoms strike with destructive energy, producing radiation that would fry electronics and biological tissue unless shielded. And heavier shielding increases mass, demanding more fuel, a cycle dictated by the tyranny of the rocket equation. The deeper we examine physics, the clearer it becomes. The universe isn't hostile by accident. It's structured to keep civilizations isolated. Time itself becomes another barrier. Near light speed travel dilates time, so a decade-long journey could mean centuries pass on Earth. Explorers return to a world unrecognizable, their societies vanished or evolved. Any interstellar empire would fragment under this temporal isolation, colonies drifting apart as if on separate planets, even within the same species. The relativistic firewall isn't a suggestion, it's a fundamental property of the cosmos, enforcing a kind of unavoidable solitude that no ambition can escape. Beyond mechanical and energetic barriers lies the subtle but insurmountable realm of temporal and informational isolation. Even if a ship could somehow survive near light-speed travel, time itself becomes an obstacle. A crew journeying at 99.9% the speed of light experiences a decade of travel, yet centuries pass on Earth. By the time explorers return, the society that launched them may have vanished, evolved, or moved on. Every interstellar voyage becomes a one-way journey through time, disconnecting civilizations from their own origins and preventing the formation of any coherent galactic network. Even a Type 2 civilization, capable of harnessing the power of an entire star, faces these temporal and mechanical limits, their colonies isolated by centuries of lag and by the sheer emptiness of space. The energy-mass equivalence problem compounds these limits. In the symphony of strings that underlies the universe, every particle is a vibration on a cosmic scale. To move these vibrations across vast hyperspace distances requires immense energy, producing gravitational signatures detectable across the galaxy. Yet our instruments, from LIGO to Virgo, detect no such interstellar traffic. The absence of gravitational echoes suggests the firewall is holding. The music of the spheres plays, but each instrument is locked in isolation, never to harmonize with another. Viewed through this lens, the Fermi paradox, the apparent silence of the cosmos, is less a question of rarity and more a consequence of confinement. Civilizations may rise and fall in mere blinks of cosmic time, lasting tens of thousands of years at most in a universe 13.8 billion years old. The odds of two civilizations coexisting within communication range are astronomically low. We are like ships passing in a night that spans billions of years, always out of sync, forever separated. Even fundamental constants, the Planck length and the fine structure constant, suggest that matter is stable, but interstellar movement is restricted. If light were faster or gravity weaker, stars might become playgrounds for civilization. But under the universe's current laws, our cosmic neighborhood is a prison of distance and time, designed not for contact, but for solitary survival. Every probe we send, from Voyager 1 and 2 onward, becomes a silent monument to this reality. They drift endlessly through interstellar space, their golden records pitted and silent, outlasting the civilizations that launched them. The relativistic firewall is absolute. As we extend our gaze, the universe's isolation becomes even more profound. The final barrier is not distance or energy, but the expansion of space itself. Dark energy, the mysterious repulsive force, making up roughly 68% of the universe, stretches the cosmic fabric, pushing galaxies apart faster than light can bridge. Even hypothetical Type 3 civilizations, capable of controlling entire galaxies, face a future where the expansion of the universe isolates them from every neighbor. Beyond the cosmic horizon, No signal, no matter how powerful, can ever reach a receding target. Data simulations suggest we are living in a rare golden age when intergalactic observation is still possible. In the distant future, the night sky will be pitch black, neighboring galaxies shifted beyond recognition, leaving only void. Quantum mechanics offers a further, unsettling perspective. Some physicists propose that our three-dimensional reality is a holographic projection from a two-dimensional surface at the edge of the universe. If true, then the limits we experience, the speed of light, the void between stars, are simply constraints in the universe's code, a rendering distance designed to preserve the integrity of reality itself. Contact between civilizations becomes not only improbable, but potentially impossible, like trying to interact with a game world beyond its programmed limits. This leads to the temporal isolation hypothesis. Across 13.8 billion years, civilizations blink into existence like fireflies in an infinite dark forest. For two civilizations to meet, they must occupy the same spatial sector and exist at precisely the same moment. The window for technological life is narrow, often only a few thousand years before extinction or self-destruction. A civilization may shine briefly, sending messages that will arrive long after it has disappeared. In cosmic terms, every shout is into a canyon where the echo returns too late to matter. The inexorable logic of physics dictates that while the universe is full of observable wonders, the possibilities we can act on are vanishingly small. We see light from ancient stars, but we are witnessing ghosts. We spot exoplanets in habitable zones, yet their presence is unreachable. Even warp drives or wormholes cannot reliably overcome the speed of light or the chronology protection that maintains causality, preventing paradoxes. In effect, the universe has built walls not only of space, but of time itself, constructing a quarantine that isolates each island of consciousness. If we step back and view the universe from the mind of God perspective, the logic of isolation becomes clear. A universe where civilizations could easily meet might be chaotic, a place of constant conflict. By enforcing distance through the laws of physics, each species is forced to confront its own challenges on its own planet. We are compelled to turn inward to understand and preserve the fragile island of consciousness we inhabit. The realization of cosmic solitude is not defeat, it is maturity. It teaches us that there is no galactic cavalry coming to rescue us. Our survival, our understanding, must be self-directed. Even in the framework of one-dimensional hyperspace, this solitude is absolute. The relativistic firewall, the combination of the speed of light limit, mechanical hazards, and temporal barriers, ensures that interstellar contact remains out of reach. We can theorize about Type 1, Type 2, or even Type 3 civilizations, but the gulf between here and there is unbridgeable. Our probes, drifting silently through the void, are not ambassadors but monuments to our limitations, carrying messages that may never find a recipient. The universe's final isolation is embedded in its expansion. Dark energy accelerates the stretching of space, moving galaxies apart faster than any signal could travel. Even the most advanced civilizations face a horizon beyond which communication or travel becomes physically impossible. The universe ensures that each galactic cluster remains isolated. Today, we can still observe our cosmic neighbors. In the far future, these galaxies will fade into invisible oblivion. Our reality may itself be a projection, constrained by the fundamental rendering limits of the cosmos. These physical limits, the speed of light, the vast emptiness, the temporal windows for civilization, act like boundaries in a grand simulation, preserving causality and preventing direct contact. Across billions of years, life may flicker into existence countless times, yet the probability of two civilizations coexisting close enough in both space and time to interact is vanishingly small. We are shouting into an eternal canyon, our echoes destined to arrive long after we are gone. Ultimately, the universe is magnificent, but designed for solitude. We can observe the wonders of ancient stars and distant exoplanets, but physics ensures that these sights remain forever unreachable. Isolation is not an error, it is the fabric of reality. And within this framework, we must find our meaning and purpose, not in galactic conquest or interstellar friendship, but in understanding and safeguarding our own pale blue dot. The universe's isolation is not a limitation imposed by technology or imagination. It is a structural feature written into the geometry of space-time and the symphony of strings that underlie all matter. From the relativistic firewall to the mechanical dangers of the interstellar medium, from the temporal disconnection of near-light-speed travel to the accelerating expansion driven by dark energy, every cosmic law works to enforce solitude. The stars play their music, but each instrument is locked in a soundproof room, never to harmonize across the void. Even theoretical constructs like warp drives or wormholes, though tantalizing in thought experiments, collide with insurmountable energy requirements. Negative mass, exotic matter, or the energy equivalent of planets are prerequisites for feats that might seem possible on paper but are impossible in reality. Every interstellar mission we can imagine remains bound by the tyranny of energy, mass, and time. Our civilization, at best a fledgling Type 1, is confined to our solar system, while the universe stretches endlessly beyond, indifferent to our ambitions. The expansion of space itself is the final cosmic warden. It stretches the universe, pushing distant galaxies out of reach and ensuring that the window for observation and potential contact is brief and fleeting. Even advanced civilizations may find themselves forever confined within their local clusters, unable to interact with the rest of the cosmos. The temporal isolation hypothesis reinforces this, showing that civilizations blink into existence and vanish before overlapping with one another. Our cosmic solitude is not accidental, it is inevitable. In the end, we are left with a profound realization: the universe is ancient, magnificent, and fundamentally lonely. Each civilization is an isolated island in a vast cosmic ocean, listening to the music of the spheres, yet unable to join the orchestra. This isolation is not a punishment, it is the structure of reality itself, compelling us to understand, protect, and cherish the fragile consciousness we inhabit. If this perspective has shifted your view of our place in the cosmos, if you feel the awe and responsibility of existing in a universe designed for solitary brilliance, don't stop here. Subscribe, join the conversation, and explore with us the depths of the cosmos, where understanding may be the closest we come to connection. Because even if the universe keeps us apart, knowledge allows us to reach farther than we ever imagined.